Hello, 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 hello. Okay, I'm gonna do. I'm gonna do some lead code. Okay, don't see that, don't see that. Lead code. The fuck? Leak code. Okay, lead code. Take a break. More lead code. Okay, let's just DSA. What the fuck? What the fuck, mate? Where the fuck is my lead code? No, don't do that. Don't do that. Don't do that. Don't do
Why?
that. Bro, what the fuck? Where are my... Notion, brother. Brother, Notion, brother. Bro, I have like so much shit. What the fuck is this then? That's what I'm talking, man. Why is there another copy? I don't... Are you guys like... Are you guys restarted? So there should be like 2 projects. What about this? Oh my god, bro. Oh my god, bro. Bro. Brother. What is going on, brother? Yo. Just
Hey everyone,
Nigga, Heil Hitler. Okay. I forgot it was live. I forgot it was live. Oh, Mark Zuckerberg, if you're seeing this, I'm sorry. Okay, I was just thinking about something. Let's just dive right into it. I want to do. Let's. 2.0. Greedy. I don't want to do greedy, brother. Just 2.0. 2.0. Okay, I can filter out by topics. Pick one. Yeah, just gonna pick a hard one though. So, question ID. Easy. That's array and 2.0 only everything else can fuck off, brother. Can fuck off. Move zeros. Have I done this? 283. Ascending. 283. Nope, I haven't done it. So I haven't done it. Nah. You can go 283. Let's just jump right into it. I want to understand the question, look into the answer, try to understand. Okay, given an integer array nums, move all zeros to the end of it while maintaining the relative order of non-zero elements. Note that you must do this in the first place without copying the array. So I need to move all of that shit in that side of the thing. Okay, why haven't I not logged in? What the fuck, brother? What the fuck, brother? Okay, I just have to move everything that side. Blah 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 blah. I'm not even gonna attempt it because I'm gonna use right. No, a left. No. Okay. Comma right is equal to 0 comma length of nums. So that will be my opening gambit. Okay. I'm gonna move all of the zeros. Let's just look into it.
Hey everyone, welcome back to your daily dose of NEET code. So today,
oh my god, a thing a nigga have to do, man. It's crazy. Some liberal, puny ass, skinny ass, like, I would fuck you up, nigga. I would fuck you up. You know what I'm saying? Like, bro, what? That's what I'm saying.
let's solve the problem, move zeros. So while this is an easy problem, it's also a pretty good problem to learn some, fundamental tricks to be able to solve harder problems. So we're given an array of numbers, and we want to move all the zeros within this array to the right side of the array, all the way to the right side, while maintaining the relative order of all the other elements that are not zero. Now, your first instinct for
I just have to go. Yeah, I just have to go. I can just use a for loop, can't I? So every time I see it, I can just remove that. Let me try. For I in nums, if I, should I go L is equal to 0. If L, that's what I is for. Yeah, I can just use a for loop. If I nums of I is equal to 0, I need to remove pop. No. Nums dot pop. I could just write 0. I don't have to call it. Now if I go here, it should what's the issue with that? What's the issue, bruv? I could just print. What's the issue? Like, what's the issue with that kind of shit? Like, you know what I mean? Like, 0, 1, 12. What? Why are you printing 3 times? Are you like stupid? Are you like stupid? You stupid. You're stupid ass. You're stupid. You're stupid. You're very stupid. You're very, very stupid. You're very stupid. You stupid, 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 stupid. Okay, let's just go here. Print. Why don't I just print nubs? You know what I'm saying? Like, just print that shit. That's what I'm saying, bro. Just have to like print it and all of that, and just figure it out on the run. You know, that's how the real G's do it. You know what I'm saying? Like, that's how the real G's, that's how the real alpha males out in these streets do it. So don't look at yourself like that, mate. Like, that is such a toxic thing to do. Yo, dude, don't say that, dude. Dude, you're making the house uncomfortable, dude. Enumerate. Chic. And I go N. I can just pop the N out. You know what I'm saying? Like, pop the. And I was saying, like, if N is actually equal to that shit, I was saying, like, what do I get? Okay, why am I? If N is equal to 0, okay, I need to pop N out. Which would be, yeah. Why? This should be over there. Let's look at it. I wanna fuck this bitch up. You know what I'm saying? So 0, that will be the first one. Okay, why hasn't it popped? Because, yeah, it got popped to the back of the line. And it is equal to 0. Wait, what? No, do not redeem. Yeah, that's what's gonna happen. So 0, this is the first. Okay, this shit got popped back. Yeah, I don't get it. Why? If N is just move on to the next thing, I guess. More to the next thing, bro. Yeah, that is not equal to. Oh, I see what I'm doing. I'm I'm looking at this thing and I'm fucking up with this one. Okay. So I shouldn't change. I should just use. I'm gonna use the thing called L is equal to 0, and no, it's gotta be. Nums of 0, right? So if L, the first element, is 0, if this shit is 0, pop that shit. Okay. Pop L. Move on to the next thing, append is 0. Do that shit. If it is not, L plus 1. Right? Bro, I'm so like goated when it comes to this shit. I'm actually like so goated. Like, can we like agree on that? Output. Why? Why did you leave me? Why did you leave me? Expected. So L is 1 now. So yeah. What is happening to L? No, go back. Go back. Print L. Let's see. Let's really check out what L is going through right now. I cannot sound like 5. Or just like adds on everything. I don't want to add. So I think L needs to. You gotta go, brother. You gotta go. If else, if it is not equal to that thing, I should probably move on to the next thing and check whether it's 0. Yeah, I think so. Did I come up with the solution myself, or did God give the solution to me? Okay, simple-minded fools. Pop L, indentation. Oh no. Okay, let's just look into it.
This problem might be. So let's just take a look at this example. All right, we've got some zeros in here, but we've also got some non-zeros like 3 and 12. The easiest way would just be to create two arrays, right? Read through every value in the input. So when we get to a 0, we could put that in one of the arrays, and when we get to a non-zero value like 1, we put that in the other array, and so we get a second 0, we put that in the
Bro, this bitch is like famous now. Isn't that crazy?
array. Then we see a 3, we put that in this array, and then we see a 12, and we put that here. And then, you know, we just basically put them into two separate.
I could do that. So I need to like, if it is not, I need to output. Fuck. I should have thought of this, low-key. If it is not found in that, I need to go output dot append. Not even append, add, insert. Insert L, no, not insert L, bro. It's insert. I can't take my eyes off you. I can't take my eyes on you. I can't take my eyes on you. I envied it. I envied it. Yo. I can't take my eyes off you. Append. Man, Borealis has such good music. I love him so much. I can't take my eyes on you. I can't take my eyes on you. I envied it. Enumerate. I hurt myself today. Fuck, fuck, fuck. To see if I feel pain, the needle tears a hole. Syntax, brother. Who cares, brother? Okay.
Arrays. Now we can combine the arrays. Of course, we want to take these zeros and then add them to the end of the array, because this is what we want the output to actually look like. We also maintained the relative order of the non-zero elements, as you can see. But the problem is that we used extra memory when we created two separate arrays. But can we really just follow this idea of, you know, partitioning these values without creating two separate arrays? Can we do it in place? Because that's really what this problem is asking us to do. Can we do it with O of 1 extra memory? And yes, you can. And if you're familiar with the algorithm called quicksort or even quick select, you are probably familiar with how to partition values in place. Now this partition algorithm can be generalized. In this case, we're doing 0 and non-zero values. We could say, you know, every value greater than 5 goes in, you know, one side of the array, and every value less than 5 goes in another side, right? We could do positives and negatives. We could partition this any way we want. But in this case, we're doing it based on 0 and non-zero values. And the reason I say that this problem, while it's an easy, is good to learn learn some fundamental tricks is because the way they worded this problem is actually, I think, intentionally trying to confuse you a little bit. They tell you to move all zeros to the end of the array, right? To the right side of the array. But they could have worded it the opposite way. They could have said move all non-zero values to the left side of the array, right? Because both of those statements are equivalent. If we move all non-zeros to the left side, then by default, we're going to have the zeros be on the right side. So that's actually what we're going to do. We're going to take this problem and kind of reverse the way that we look at it. We're going to solve the opposite problem, which will still give us the intended result. So this is the input array that we're given. Now, while we're going to do this in place, I want you to pay attention to, in this case, we already know that there's 2 zeros, so I want you to kind of pay attention to this portion of the array, these last two, because we know this is where the zeros are going to end up, and the first 3 is where the non-zeros are going to end up. So, it's kind of like we have 2 separate arrays, but we're doing it, with the memory that we have. But so how can we partition this and still maintain the relative order of these values? Well, it's very simple. We know the non-zero values, we have 1, 2, 3 of them, they're all going to end up in this portion of the array, these 3 positions, right? What we're going to do is have a pointer. We know that the first non-zero value is going to go here. I'm going to call this L for the left pointer. And basically every time we see a non-zero value, we're going to take that non-zero value and, let's just run through the example just to make it clear. So the first value is 0. When we see a 0, we don't do anything with it because what we're trying to do is take all the non-zeros and move them to the beginning. So we see a 0, we don't do anything, but then we get to the next value, it's a non-zero. What are we going to do? And by the way, as we iterate through this array, we're going to do that with our right pointer. So I'm not going to show it, but just assume that our right pointer is over here now. It started at the beginning at the same spot as the left pointer, but now it's at the next index. So we see a 1. What that tells us is we're going to swap this value with the value at the left index. And so by doing that, we're going to basically put a 0 over here and put a 1 over here. Next, our right pointer is going to be over here, and we see a 0. So nothing for us to do again, right? When you see a 0, we don't do anything with it. Okay, so now, since we put a value at the left index, we don't want to leave our left pointer over here. Now we want to actually shift our left pointer to be at the next position, because here we already have a non-zero value. The next time we see a non-zero value like this 3, we want to put it over here where there is a 0 value. And our right pointer was over here previously. Now we're going to put our right pointer over here. But before we even continue, just notice this array. We have visited the first 2 values, right? The first 2 values are already partitioned, right? We have a 1 at the beginning and then we have a 0, right? That's what we wanted to do. We wanted to put all zeros at the right side and all non-zeros at the left side. So we've already done that, but we've only done it for the first 2 values. So let's continue. We get to the third value over here. It's a 0. We don't do anything with zeros, remember? We ignore them. We leave them as they are. So again, the first 3 values now are partitioned, right? We have a 1, 0, and a 0. Next, we get to this value. We put our right pointer over here. It's a 3, so it's a non-zero. So we swap it with the value that is at the left pointer. So we put a 0 over here and we put a 3 over here, right? And now our left pointer from this position is also going to be shifted over here. And once again, you can see that the array is partitioned, right? The first 4 values at least, right? Because those are the ones that we visited so far are partitioned. Lastly, we're going to visit the last element over here. It's again just going to be swapped with the value at the left pointer over here. So we can put the 12 here and then we can put the 0 here. So as you can see now, our array is 1, 3, 12, 0, 0. That's exactly what we want to do. We maintained the relative order and we partitioned it. We put the zeros at the right side. That's the entire algorithm. Now let's actually code it up. So now let's code it up. So like I said, we're going to have 2 pointers. The left pointer is initially going to be at the beginning. The right pointer is also going to be at the beginning, but the right pointer is going to iterate through every single position in the array. So it's going to iterate through the entire length of the input array. And we had a very simple condition, right? If the number is 0, we ignore it. If the number is non-zero, so if this is non-zero, then we do a swap operation, right? We swap the left index with the right index. So we can actually do that with one line of code in Python, but in some languages, maybe you can use a helper function, like a built-in library function, or you can just, create a temporary variable and then do the swap like that. But in Python, this is how we're going to do it. We can do it with one line of code. So we're assigning the right value to the left position. We're assigning the left value to the right position. And remember, every time we do a swap, we want to make sure we increment the left pointer. The right pointer, though, is going to be incremented on every single iteration of the loop from the for loop. But that's actually the entire code. I know it's probably looks easier than you might have expected, but this is definitely a useful problem. Let's run it to make sure that it works. But this algorithm is definitely useful. It comes up in many other algorithms as well. Like I mentioned, quicksort and many other algorithms. As you can see on the left side, yes, it's very efficient and it works.
Fuck. Is that what it is? So let's just add 283 and go easy YouTube solution. I haven't done it myself, that's what it means. So I just need to go left. Yeah, I don't have to do this nums, this weird shit. I could just go here and I could go for I in right in nums. Okay, it's gonna iterate. Both of them are gonna iterate if I got that right. Let's try that. If R is equal to L, no, if R is equal to 0, right? I need to go nums of R equal to nums of L. Oh, I just wanna. I've made some mistakes. Okay. If R is not equal to 0, it will automatically iterate. Nah, I don't think it's an if condition at all.
The right value to the left
What the fuck is this? If nums of
position,
R.
we're assigning the left value to the right position. And remember, every time we do a swap, we want to make sure we increment the left pointer. The right pointer, though, is going to be incremented on every single.
The fuck does that mean? So he does one of these. What the fuck does that mean? That's what it means, right? I'm increasing the
iteration of the looks sure that it works. But this algorithm is definitely useful. It comes up in
range of nums. What the fuck does that mean? Okay. It's the same thing. Why you throwing me off? Why you throwing me off? Man, I just wanna range. No, don't do that. Range of length of nums. Okay. I'm gonna get a cramp. I am gonna get a cramp. Bandania Narayana 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 Bitches come and go, brah. Bet you know, just come and go, brah. Got my balls licked by your surgeon ad. The fuck? That's what I'm saying, bro. It ain't sunshine and rainbows out here. You know what I'm saying? You know what I'm saying? Like, Narayana, Narayana. I was confused with the line. I thought he didn't wrote the whole condition, but I realized if it is present, it will return true. If not, false. Narayana, 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 Are la la yamuni, Narayana, Are na na no, okay. Narayana. Let's put this comma. Narayana. Are. Just come and go, bro. Okay, submit. Bro, look at the time complexity. Everyone copied NEET code. Literally everyone. What is the solution? You know what I mean? Every one of you motherfuckers copy NEET code. Don't even. Bro, what the fuck is this? Like 2 for loops? Are you fucking retarded? Are you fucking retarded, bro? 2 for loops? Are you that retarded? To do food? Oh man. Who the fuck did this? You're a retard, bro. You're a retard if you did that. 2 for loops. Are you fucking okay? Is everything good? Nah, bro, I don't need you. Oh, fuck. It's like I'm punching myself in the foot, in my thigh. Every time I do that shit. Okay, bro, why can't you just memorize what I just wanted out of my code? You know? It's like, are you out of your mind, bucko? Are you out of your mind, bucko? Do you want a piece of this? Let's go another two sum. 2-pointer. Fuck, two sum. You know what I'm saying? Like, you know what I'm saying? 2-pointer sorting. Nah. Duplicate from. Bro, I should have done this. 26. I've done 27. I've done 27, but let's just go here. When I get stuck, first thing that I do, NEET code 2-pointer. Brother, I don't give a fuck, brother. Okay.
Hey everyone, welcome back, and let's write some more NEET code today. So today let's solve the problem remove duplicates from a sorted array. So while this is an easy problem, it does have a ton of dislikes, so you can assume it's going to be a little tricky for an easy problem, but I don't think it's too bad. Maybe the dislikes are just kind of from the long description and the way you solve this problem. But mainly we're given a non-decreasing order array. By non-decreasing order, they literally mean increasing order, or rather sorted in ascending order. So I don't know why they don't just say sorted in ascending order. It seems like they're purposely trying to be confusing, but if you take a look at this example input array, you can see it's sorted in ascending order. Now there are duplicate values, which is why they say non-decreasing order, because technically duplicate values are not ascending, they're equal. But basically our job is to take this array that could have duplicates and is in ascending order and then convert it into a new array where we remove the duplicates, right? So you can see we've taken this array and then removed the duplicates, and this is still in ascending order, right? It's still sorted, but now the duplicates are gone. And the difficult part about this problem is they want us to do this without any extra memory, so they want us to do it in...
I think it's similar to what we just did, so... Is it similar? What that mean, nigga? What that mean? What that mean, nigga? Okay, 283, 283, 283, 283, 283. Ooh, what you say? Oh, la la. Okay, I think I got this. So, what the fuck? Don't do that. Reset. wait. What? Print reverse nums. Oh, I was just checking this thing. Fuck! Can you just go away? So what I need to do is L is equal to 0 for I, for R in range, the entire thing, num of nums, fucking hell, bro. Alhamdulillah, bro. Alhamdulillah. Alhamdulillah, brother. And so that is for R, right? So if nums of R exist, which it does, I do wait. No. No, if it has duplicates, that's the difficult part. Okay, if it has duplicates, it doesn't want me to create another memory. So if it has duplicates, if it has duplicates, meaning output 5, so 5. Oh my god, here we go. I can't do it. This is too difficult.
In place, right? So of course, if we're given an array like this one and we do it in place, we'll get the the desired output, but we'll still have some extra memory in the input array, right? We'll have extra memory. It doesn't matter what we put here in the extra memory. That's just something we have to keep in mind. And the return value in this case is not going to be the input array. We're actually, for the return value, going to return how many unique values are in the input array. In this case, you can see 5 unique values, which matches what we have down here, right? 5 unique values. So we return a value of 5, but we also want to make sure that we update the array into this format. So we can't just return 5. We still have to update the array. So this problem is definitely best understood with an example. So remember when I said that we want to count the number of unique values? So how exactly is this problem going to work? For example, the first unique value that we read, where are we going to put it? Well, we want the output to also be in ascending order, sorted, right? So of course, the first unique value we're going to put in the first position, right? In index 0. The second unique value that we read, where are we going to put that value? Of course, we're going to put it in the second position, right? That's the only possible position we can put it if we want to maintain the sorted order, right? The third is going to go in the third position, the fourth is going to go in the fourth position, and the last unique value is going to go in the last position. Obviously, if we could allocate extra memory, this would be pretty easy, but we have to do it in place, right? We have to do it within the array. So really, when we say we read the 0th value, we're going to leave it in the 0th position, right? So basically, the first value in the array is definitely going to stay in that position. Now, the second unique value is going to go in the second position. It might, maybe we don't even have a second 0, right? That would mean that the second unique value is just going to stay exactly where it is. That would be simple, but in this case, that's not the case. So in this case, we have to put this value in the second position, which means we're going to go here. And of course, this 2 would go in the third position. So what we're realizing is it'll be good for us to go ahead and scan through the array with a single pointer, but it'll also be good for us to have a second pointer. We can call it the left pointer, which is going to tell us next time we see a unique value, such as let's say 3, where are we going to put it? Well, we're going to put it wherever the left pointer happens to be. By the time we get to 3 as a unique value, we want our left pointer to have been here to indicate that we already put a 0 here, we already put a 1 here, and we already put a 2 value over here. So this will definitely be doable if we have 2 pointers, right? One pointer scanning through the array, we'll call it the right pointer, and a left pointer telling us where we're going to put the next unique value. The left pointer will also tell us how many unique values we've already seen so far. So the left pointer will actually take care of the output parameter for us. Because every time we see a unique value, for example, we see 1, we're going to put 1 over here, and then we're going to take our left pointer, increment it by 1, and then put it in the next spot.
So if right pointer is at the unique value, swap that shit with the, okay, that's
right, so it'll tell us how many unique values we've already seen so far. So now that we know how we're going to solve this problem, there's just one catch. How do we know, as we're scanning through the array, looking at each value, looking at some random value, how do we know if this is a unique value or not? Or meaning if this is the first time we're seeing this value or not? How do we know that? Well, just by looking at the picture, you might be able to determine it yourself. For example, if we saw this 1 for the first time, and remember the fact that this array is going to be sorted in ascending order, we can take a look at this value and compare it to the previous one. This is 0, this is 1. That must mean that this is the first time we're seeing a 1 value. What about when we get to this one? We'll compare it with this guy. This is a 1 and this is a 1. So of course, this is not the first time we're seeing a 1 value. We're just going to ignore it and then go to the next value. And by the time we get to the 2, we'll compare compare these two. 2 is not 1, so that's the first time we're seeing a 2 value. So it's actually not that difficult. So in the next 60 seconds, I'm just going to go ahead and do an example. So we're going to initialize both pointers left and right at the second value. Why are we doing it here? Because we know that the first value, we're never going to update this, right? It's going to stay exactly where it is. Now we're going to take a look at whatever value our right pointer is pointing at, compare it with the previous value. They're the exact same, so we're not seeing a 0 for the first time. That's perfectly okay. Now we shift our right pointer over here. Left is going to stay here because we never put anything there. Now our right pointer is here. Let's compare these two values. They're not the same. So that means this is the first time we're seeing a 1 value. So that means we're going to put this 1 value wherever our left pointer happens to be. So we're going to go ahead and put this 1 value over here. And since we put a value at the left pointer, we can go ahead and take our left pointer and then shift it over here. And also let's shift our right pointer as well. So now again, let's take a look at the value at the right pointer. They're the exact same, so we don't do anything. We can shift our right pointer one more time. Exact same values. So again, let's shift our right pointer. And now we finally see a new unique value, right? Because this 2 is not the same as the 1. It's a new value. Let's put this 2 wherever our left pointer happens to be. Right now the left pointer is over here. Let's put a 2 over here. So when we do that, remember we have to shift our left pointer. So this is the next spot that the next unique value is going to go at. So let's shift our right pointer again as well. These two values are the same, so we don't see a unique value. Right value is going to be, right index is going to be here. Now we do see a new value that we haven't seen before, a 3, right? So the 3 is going to go wherever the left pointer is. That means the 3 is going to go here. Left can be shifted by 1 again, and right is going to be shifted again. Right is here. 3 and 3 are the same, so we shift right again. Now right is going to be here. 4 is a new value, right? It's not the same as 3. 4 is a new value. We can put 4 wherever our left index happens to be. Let's put 4 over here, and then increment left again over here. Let's also increment right. Now we went out of bounds, right? So since we're out of bounds, of course we know we can stop the loop. So what are we going to return now? What is our left index pointing at? What's the value of left? Left is at index 5, right? So we're going to return 5, just like the output wants us to do. And you can see that the values that are expected in the output is exactly what we have, right? We have 0, 1, 2, 3, 4. So we were able to solve this problem in big O of n time because yes, we're going to be having 2 pointers, but each pointer is just going to be iterating through the entire array once. So you can assume that the time complexity is something like 2 times n, which is exactly a big O of n, right? So with that said, we can finally get in the code and it's going to be pretty short. So first thing we want to do is initialize our pointers. Like I said, we're going to start at index 1. So I'm going to set our left pointer equal to index 1, and then I'm going to have our right pointer be iterating through pretty much every single value in the input array, which is what we want to do. But instead of having it start at 0, I'm going to have it start at 1. So basically both our left and right pointers are going to be initialized to 1. And remember, the only thing we need to check is the value that we're seeing right now, the value at index r, is this value a new value or is it a value we've already seen? How do we determine that? We can determine that by comparing it to the value that came before it at index r minus 1. So if they're not the same, that means this is a new unique value. What do we do with the new unique values? We put them wherever our left index is. So we can take this new unique value that is at index r and place it at index l, or at the left index. And remember, every time we do this operation, we want to make sure that we remember to increment the left pointer. And we're only going to increment the left pointer when we do this operation. If we don't do the operation, we don't increment the left pointer. But we are always going to increment the right pointer, but I don't have to put that here because the for loop is going to handle that, right? That's why I don't need this line of code. The for loop is going to make sure to increment r each time. And once that's done, we have to return how many unique values are in the array. And we know that our left index can handle that for us. So we can just return left. Now you're probably thinking, what if we had an empty array of nums? Then wouldn't we want to return 0? And you're right, but for some reason, LeetCode accepts this as well. So I think we're good to keep this code pretty simplified. So this is the entire solution. I'll run it to make sure that it works. And as you can see on the left, yes, it works. And it's about as efficient as you can get in terms of overall time complexity because this is a linear solution, no extra memory needed. So I hope that this was helpful. If it was, please like and subscribe.
So I'm starting from the second position and checking if it's a new value. It is not equal to the previous one, right? If it is not equal to the previous left, I'm swapping the left to the right. This is the right will be the new left, and I'm incrementing it. Okay, I think I can do it. Yeah, I think I need to start from 1, which was a really good intervention by myself, I should say so. I need to start this one from 1, 2. And if, so here's the thing. If nums of r is not equal to nums of r minus 1, if it is not equal to that, if it is equal, that means it is a duplicate. I'm at a duplicate index. If it is not equal, it's a unique value. When it's a unique value, I need to switch nums of L. I have to do small l from now on. And to switch the positions and move on to the next thing. Move on to L plus 1 and return L. Return the num on this thing. Yeah, it works. Cool. Bro, everyone copied this. Come on, bro. Come on. I think that's like the best way to learn too. So I don't really mind it. Don't really mind that, man. La 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 so la 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 so la.
Hey everyone, welcome back and let's write some more NEET code today. So today let's solve the problem remove element. We're given an integer array of nums and a particular value, a second parameter value, and we want to remove all occurrences of this value that we're given as the second parameter.
Okay, I think it's similar to that one. Let's give it a try. If it's like too hard, nah bro. If it's like too hard, I'm just giving up. I'm just gonna give up. It's not actually giving up, but it is what it is. Yeah, so I should do it in n of whatever complexity. Did I add fuck, I like my life. 11 solved. Isn't that crazy? Okay, what did I do? Move zeros. Bro, why did I... Okay, I learned a lot of things from here, but I did not solve it. Bro, looks dead. This shit looks dead. Brother, give me the fucking thing, man. Bro, can I like get a normal view of things, please? 26. I'm gonna do 27 now. It's so it's similar, I think. So 27, remove duplicates in what? And I need to return the duplicate number. And that's just yeah, L. Okay. What the fuck? Yeah, this one. So remove element that are, if it's 3, I need to remove the value 3. Okay. So left is equal to, I don't want to do left prop. L is equal to 0 for R in I don't know why I'm doing range, but that seems to work. Length of nums. Right, I'm iterating over the entire thing. If I find the value 2, so if R finds the, okay, no, don't do that. If R finds equal to the value, right? If num of R's, of course, finds the value 2, I should pop that shit. Okay. Num dot pop, and I need to add a pop. What should I pop? I should pop R, right? Yeah, I should pop num of R's out of the group. And I should go L plus equal to plus fuck Oh, it's tiny. I need this. Plus equal to 1. And I need to return L. Let's give it a try. If it is equal though. If it's not equal, should I just pop? No? I'm iterating value. It's got to be an integer. And nums of R is going to be a number. Don't you think? Index, fuck, yeah. Fuck's sake, bro. I had a fishy feeling about writing that. No pun intended, though. No pun intended. Not sound like no pun intended. She. Line 5, remove solution what? Value is equal to 3. I'm removing, I'm not popping the element, fuck. Yeah, it reduces the whole thing, right? So I'm not really popping the thing, I'm just going nums of R, no, nums of L is equal to nums of R. Okay, I'm swapping that thing. It's coming forward though. So it should be the other way around, right? So nums of R is equal to nums of L. Okay, let's just look into it.
We want to remove all occurrences of it from the other parameter, the nums array, and the trick here is that we want to do it in place, meaning we want to do it without allocating another array. We want to do it just with the input array that we're given. So basically, if you read the next paragraph, since we want to do it in place, the main way that they want us to actually implement this is by taking all the values in the input array nums that are not the particular value, and then place all of those at the beginning of nums. So suppose we had k values in the array nums that are not the value, the special value that we want to remove, then we would return k saying that, okay, there's k values in nums that are not that special value, and all of those k values have been placed at the beginning of the array in place. That might seem kind of complicated, so it's best understood with an example. So take a look at this input array that they are giving us, and the special value that we want to remove is value 2. So we want to remove all occurrences of 2 from this array. Now, by remove, they don't just mean delete the value, they mean do it in place. So in the output, you can see this is what we want the array to look like. So you can see that all the values that are not 2 have been placed at the beginning of the array. The relative order, as you can see, does not actually matter, right? Like 4, 0, 3 is not the
Okay, now I understand the question better. Yeah, if it is actually equal to the value should be banished. Like, I mean, banished to the outer world. But who cares?
Order that they appeared in the input array. In the input array, they were given as 3, 0, 4. So it doesn't matter what order we do it, but we have to put all the values that are not 2 at the beginning of the array. But this array, this output array, is not what we're actually returning. We're just returning 5, indicating that there's 5 values in the array that are not 2. And like I said, the trick to doing this is doing it in place without allocating any extra memory, as you can see up above. So returning the value itself, 5, would be easy in this case, right? It's easy to count which values are not 2. But doing the actual in-place modification is tricky if you're a beginner, so let me explain it. So how would we want to do this? Of course, we can see the first 2 values. These are not 2, so we don't have to do anything with them, right? Okay, the next values are 2, but we can't just delete them, right?
I need to compare.
Right, we have to replace them with other values that come after them, right? Basically collapsing these values onto the 2s that we want to remove. So we read the 2s, then let's say we get to a 3, right? Where do we want to put this 3, right? We don't know that there's anything else in the array. There could be, there might not be. Where would we want to put this 3? We could put it in this spot, replacing this 2, but it would be much better to put it over here, right? Replacing this 2, because we want to put all the values that are not 2 at the beginning of the array. So it's better to put it here. So suppose we do that. We replace this with a 3, and the real 3 can just stay here for all we care. And then next, we're going to get to a 0. So this is also not a 2, and we want to put this over here, right? We know there's another 2 over here, so let's put the 0 over here, right? So basically what we're learning by just going through this example is it might be very helpful for us to keep a pointer, let's call it k, or let's call it I, or whatever you want to call it, a special pointer basically telling us next time we find a non-2 value like 3, 0, 4, where should we put it, right? We should put it replacing the 2, wherever the first 2 happens to be. And then once we do that replacement, right, we'll take our I pointer and then shift it by 1, saying, okay, next time we see a non-zero value, like 0 in this case, then put it over here. And then again, we take our I and then shift it. But this time, see our I pointer at 4 already took this. Okay.
happens here? And then no, because we only want to put non-2 characters at the beginning of the array, right? We don't care about the actual 2 character. And I've been using I for this, but it's probably better to use K. This K value will actually be the output value that we end up returning in this problem, because this K is going to be incremented every time we see a non-2 value. So it'll tell us by the time we've reached the end of the array, it'll tell us how many values are in the array that are not 2. So that definitely makes sense for us. Now, one thing you might be wondering is, we initialize our K pointer over here, but isn't the K pointer initially going to be at the beginning of the array? And, suppose we didn't even have any 2s at all. What are we going to do in this case, right? We're going to say, okay, we have a 0. This is not a 2. So does that mean 0 is going to be swapped with itself? That doesn't really make sense. And then would we want to still shift our K by 1 because we didn't see a 2 in this position? And you're right. It doesn't really make a lot of sense to do it, but it elegantly does work out with the code, right? For example, if we did not have any 2 characters, right? Suppose these didn't exist and this didn't exist. How would the algorithm that I'm explaining, how would it actually run? Well, we'd see a K. We'd start with a K here. We'd say, okay, this is not a 2, swap it with itself. Okay, then K gets incremented by 1. This is not a 2, swap it with itself. Okay, K gets incremented by 1 to over here. Swap it with itself. Swap this with itself. Swap this with itself, and then we're done. And then by the end of it, our K pointer would be over here. It would be at position 5, and we would want to return 5 because that's the number of non-2 values in the array. And then this is what our array would look like. We didn't actually modify the array at all if this was the input array itself. So you can see that this algorithm, it's simple, but it does work in all the edges into the code. So just going to ignore. I want the val. So if this is not equal to that special value, that's when we're going to be performing the swap. If we do see that special value, then we can just ignore it, right? We don't want to take that special value and then push it to the beginning of nums. We don't want to do that. And basically from what I'm writing, you might actually recognize that this algorithm that we're doing is kind of similar to the partition of like a quick sort or quick select. By partition, in this case, we're taking all values in nums that are not.
It's a quick sort thing.
This particular value and then putting them at the beginning of nums. That's what we're doing when we say partition. If that makes it easier to understand for you. But like I said, so if it's not the special value, then we can take this and then put it at our index K, which tells us where to put the next value. So we'll put nums of I at
my life. Okay, 1 hour of lead code. What should I do? What should I do? I'm gonna come back, play some Elden Ring. I'm so unserious. What am I gonna do? What should I do? Yeah, come and do some more 2-pointer. What else can a negative? Okay, when it's not equal.
Position K, and then we will
K is equal to K.
Increment our pointer by 1.
K is equal to K. What the fuck? R is equal to R. I need to increment the pointer.
This should be an I, not a K. So then
bro, that's the exact thing that I made. Like, what the fuck?
we'd increment by 1, and then if it is that special value, then we won't do anything, we'll just skip it. And then once we're done with this, remember what we actually want to return is K itself. We don't want to return nums, we want to return K. So that's
bar for bar, word for word, the exact same code. Wallahi, bro. Wallahi, Allahu Akbar, bro. Allahu Akbar. If why is double equal? What's wrong with that? Bro, what the fuck is wrong with that? I don't even see a difference. It is exactly equal to that one, and this is just okay. My value is bro, I need to write a paragraph. 27. YouTube. I haven't completed myself. Yeah, this shit gotta go. This shit is... trips me out. And Oh, the buzzer has a DDA, man. Duplicate zeros. Let's go. That's what I need to do. I need to go here. Yeah, never attempt yourself. This is such an outdated way of like looking at things. I'll just figure it out later. Yeah. I need to write shit down. Fixed Notion tags. Fuck. Okay, and let's go here. Oh, I've actually attempted it. Fuck. Okay, I've actually attempted it, but